All right, Algebra 2, we're just going to review a little bit of what we know of exponents. You guys can remember that when I have x squared times, I think that says x to the third, when I multiply, I add. And like we reviewed yesterday, when I have a power to a power, a to the fifth, all of that to the second power, I'm going to multiply, a to the 10th. So we are moving on to lesson 10.2. It's called Real Number Exponents. And our essential question today is, can you extend the meaning of exponents to include irrational numbers and to define exponential functions? You've probably been hearing the word exponential a lot. So we are just going to talk about what to do here and go back to the basics of exponents. So let's go ahead and look at example 1. All right, so let's take a look. If I have 6 to the root 2 over 6 to the negative root 2, remember that when I have a negative on the bottom, we can bring it to the top. So really this is saying 6 root 2 times 6 root 2. And one thing we're going to get a little confused on is we always have to go back to the basics. So remember, when I multiply, I'm multiplying these. I add. We keep the base the same, and I know that root 2 plus root 2 is 2 root 2. So the answer here is 6 to the 2 root 2, or you can also go ahead and multiply these and make this 36 to the root 2. Now remember that 36 didn't come from multiplying these, because remember when I multiply, I'm just adding the exponents. I actually don't touch that. So let's go back to that. A squared times a to the 5th is a to the 7th. I never multiply the a's. All right, let's go ahead and look at example 2. We have a problem on this one. The first problem is they are not in the same base. So the first thing I want to do is I want to put this 4 as 2 to the 2 pi. And I'm multiplying this by 2 to the 3 minus 2 pi. Let's go back to the basics. When I multiply, I'm going to add. So this is literally saying 2 pi plus 3 minus 2 pi. Most of you have already figured this out in your noggin, that you could go ahead and get rid of the 2 pi minus 2 pi. So my answer is 2 to the 3rd, which is 8. All right, I'm going to move on to some multiplication and some harder ones. Some of these answers you could find in the book. Some of these you could look at right in the book. Let's go back to the basics. When I have a power to a power, I multiply. So this is literally saying 5 to the, that's a root, sorry, this is a root 3 and a root 3. So I'm actually multiplying 2 root 3 times root 3. So this is 2 times, well, root 3 times root 3 is just 3, correct? So we know this answer is 5 to the 6th power. Now, if you were doing this without a calculator, I would not make you work this out. But in this case, you should have a calculator, and you could put this right in as 15,625. All right, the last one I'm going to do, because I want to keep it short, is this equation. Remember, an equation is when you have an equal sign. Typically, we're just simplifying, but in this case, we're going to go ahead and solve the equation. The first thing I know is that I have to put these in the same base. So if I have 4 and 2, I know, well, this is 1/2. I know that we have to go ahead and put them in base 2. Well, 4, I'm going to write that darker. 4 is 2 squared, and all of that to the 2x. And 1/2, remember, is going to be 2 to the negative 1st, and all of that to the 1 minus 2x. And remember that we'll have to distribute because it's a power to a power. So my next step would be to do the powers to a power. So I know that this power to a power is going to be 4x. So this is going to be 2 to the 4x. And if I distribute this, I'm going to have 2 to the negative 1 plus 2x. So because we are solving for x, we're actually, because of the same base, we can take out this because they are equivalent, and we can go ahead and make a whole new problem. So I'm going to do that. And my new problem in this case is 4x equals negative 1 plus 2x. So now we're just going to go ahead and solve for x. The first thing we have to do is subtract the 2x over. 2x equals negative 1. And when I divide each side by 2, x is equal to negative 1/2. All right, we're going to look at one more just so we're all on the same page. I'm making this lesson a little longer. My apologies. Well, I know if I have 5 to the 3x is equal to 1 over 25 to the x minus 1, because of the 25 and the 5, I can put these in the same base by going ahead and making it 5, because I know 1 over 25 is 5 to the negative 2. So all I did is I changed the 1 over 25 as 5 to the negative 2. And now we have to go ahead. This has to distribute. So I'm going to rewrite this as 5 to the 3x is equal to 5 to the negative 2x plus 2. And from here, because we have the same bases, we can go ahead and take out our exponents and make it equal. So my exponents are 3x equals negative 2x plus 2. When I add the 2x over, 5x is equal to 2, and x is equal to 2 over 5.